Hello students, in the today's class we are going to start the electrochemistry chapter. In the electrochemistry chapter, firstly we need to understand what is the meaning of the electrochemistry. With the name, we can easily understand there is an interrelation between the electricity and the chemical species. Electro means electricity, chemistry means chemical species are involved here. So we can easily understand that there is an interrelation between these two things. Now, electrochemistry deals with the study of electrical properties of solution of electrolytes. See students, you will see in the chemistry there are so many compounds like NaCl. When you are talking about this NaCl, it is in the fused state. If it is in the fused state, what you will see, if it is in the solid state, its ions are completely packed. They are completely closed in a lattice structure. Now in the fused form, you will see that it is in the molten form. So once you will apply a very small electricity, it will be simply divided into the ions. Now with the help of electrical energy, if this NaCl would divide into the Na plus and Cl minus, so can we say with the help of electrical energy, you have formed the chemical species like sodium ion and the chloride ion? Can we easily understand with the help of this? Yes. So now the electrochemistry deals with the electrical properties of solution of electrolytes. What is the meaning of electrolytes? Those substances who are capable to pass through the electricity through it. These are your what? Electrolytes. Okay. Now electrolytes are what? NaCl, can we say in the fused state it would act as an electrolyte? When you will take its a solution in the aqueous form, as well as what you will find when you are passing the electricity through it, it will be simply formed, the ions species will be formed there. Now here we can easily understand the electrochemistry is nothing but there is a relationship between the electrical energy and the chemical species. Further in detail we will study. Now after this electrochemistry, we need to understand what are the conductors and non-conductors. See students, today we have studied about the electrolytes. Electrolytes are what? They have a capacity to pass through the electricity through them. Now we need to understand those which are the substances, those are capable to pass through the electricity through them, and those are not capable to pass through the electricity through them, if we want to understand about the electrochemistry. So firstly we are going to understand about the conductors and non-conductors. Now what are the non-conductors? Non-conductors, those substances which do not allow the electric current to pass through them. These are called as what? That are your non-conductors. See students, in the pure water, as we know, you have an H2O molecules. In the H2O molecule, what type of bond is present here? That is covalent bond is present here. Okay, which is formed by sharing of electrons. So to form the ions like H plus and OH minus, it will be easy here. No, it's not easy for us in the pure water if you have only the H2O molecules to form the H plus and OH minus ions. If you will simply pass the electricity through the pure water, and if you would expect that it would be simply divided into the H plus ion and OH minus ions, so it's not possible. So here we can understand those substances that cannot divide into the ions and they are not capable to pass through the electricity through them, that are known as your non-conductors. They have no capability to pass through the electricity through them. See, we need to understand, a student, firstly about the current. Current is what? The flow of the charge, that is known as your current. So charges can be flow. There's something, a mediator must be there. There's something, must be a carrier, something there must be there na, that can pass through them. So here in the pure water, if you don't have any free ions, so how they would conduct the electricity, how the charge carriers will flow? Okay, to pass through a charge carrier from one place to another place, you need some another charge carriers that would carry some charge and they would just drift them and to flow them from one end to another end. We are understanding? So if you don't have any charge carriers, any free ions, then how the electricity would be passed through them? It's not possible. So these are known as your non-conductors. Similarly, we can understand the ice. In the ice, you have what's the chemical formula? That is H2O, pure water. So it has no free ions. If you don't have free ions, all the molecules, they have a covalent bond. They don't have a capacity to be into the ions form in H plus and OH minus once you will simply pass the electricity. So they are known as your non-conductors. Simply the glass we can easily understand. Glass is also the same type of material. It don't have any capacity to pass the electricity through it. Now, next point is conductors. What are the conductors? Substances which allow electric current to flow through them, that are known as your conductors. See students, as we have studied about the non-conductors, they have no capability to pass through the current through them. Okay, because they don't have any charge carriers, don't have any free ions. Now in the conductors, they have a capability to pass through electric current through them. How it must be possible? There must be some charge carriers must be there now. So here we can easily understand the examples like metals. In the metals we know, suppose we are taking the example of copper wire or any copper metallic sheet we are taking. It is made up of copper atoms. In the metal atoms, in the valence shell, you have the free electrons are present there. If you have a free electrons are present there, so these free electrons are known as your charge carriers. As you will observe, once you will apply the battery through this metallic wire, what would happen? The current will be passed through it. You would observe the current will produce here only. How it would be possible? Because the charge carriers electrons are present here. They are present. They would pass the electricity through them. Now, aqueous solution of acids, bases and salts. See students, once you will take an example, as we can easily understand, here we have an example, aqueous solution of acids and bases. Suppose you have this jar. In this jar, you have filled the HCl acid. Okay. Now here, this is a metallic rods. These rods have some charge. It is a positively charged plate. It is a negatively charged plate. With the help of a metallic wire, you have connected a battery through here. The positive plate of the battery which is connected here with this plate. Now this plate that contains that carries a positive charge, that is known as your anode. And the negative plate that has, this plate has some negative charge. It is known as your cathode. Okay. Now here, once you will pass the electricity through them, what would happen? Once the current will pass through here, this HCl, which is in the molecular form, it will be divided into the ionic form H plus and Cl minus easily. Yes, we can easily understand. And these plates have opposite charges. So they would attract the opposite charges to their Cl minus would be attract towards to this positive plate, and the H plus which has positive charge would be attract towards to this negative plate. So what we are observing over here, in this hydrochloric acid electrolysis, these the charge carriers, these are the ions. They are capable for what? They are capable for electricity conduction. So here we can easily understand these are capable to pass through the electric current through them. They are known as your conductors. They are capable. They have simply the simple electricity is passing through them, and what we are observing, they would simply divide into the ions, and these ions would just go to the opposite electrodes. Now some students would ask me, ma'am, why we have called that they would allow the electric current to flow through them? How the electricity is producing here? You have simply passed firstly electricity, ions are producing here. Now how the electricity is flow through them, electric current to flow through them? So we can easily understand, once the electric current is passing through them, what would happen? It would be simply dividing into the ions H plus and Cl minus. Now Cl minus, once it will go here, we would understand there would be some process occurs on here. On the anode, what would happen? See, it is in the ion form, and this is the metallic rod. This is what your electrolytic conductor. So you can say between the metallic and electric conductor, when this ion at this part, at this portion, it would simply, to just deposit on this metallic rod, it has to lose its electron. So once it will lose its electron, what would form? The chlorine atom will form here. So here the electrons which are producing here, what would happen if the current is flowing in this direction? The electrons will flow, they would go into the opposite direction. Once the electron will go into the opposite direction, it will go on here on this side. What would happen? Here the H plus ions are there. They would easily gain this electron, yes, and would convert into the hydrogen atom. And similarly, you would observe after some time hydrogen gas would be there. We can easily understand. So students, by this phenomena, you can easily understand when the current is passing here only. So current is coming from this positive terminal. Current conduction is possible when? We can easily understand when we talk about the current conduction. So complete current conduction is possible when the current will flow from positive terminal to negative terminal. This is known as your complete current conduction. Okay, so once the current is flowing through here only, what you are observing? You are observing that it has simply dividing into the ions. It has not reached here. It will reach here when you are observing that electrons will flow from here in this direction. So current will be in the opposite direction. The current will be starts flowing. So the current is passing from here to here. So the current conduction has been possible or not? From this direction to here it is possible. Okay, so now the current conduction from positive to negative terminal, how it's possible? With the help of these free ions. These free ions, these are responsible to produce the electrons. Due to that electrons, you are observing that the current is conducting through this electrolytic solution, and through the complete circuit it will be happen. Okay, now here we can easily understand they are capable to pass through the electric current through them. That is known as your what? That is known as your what? These are your conductors. Okay, now here conductors are dividing into the metallic conductors and electrolytic conductors. We can easily understand what are the metallic conductors. The conductors which conduct electric current by movement of electrons without undergoes any chemical change. These are known as metallic conductors. See students, we can easily understand metallic conductors with the help of this. Suppose you have this copper wire, the copper rod, and you have this copper atoms are present over here. What would happen? In this atom, you have a valence shell electron. Each and every atom that has a valence shell electron, as we know that it is loosely bonded by its nuclei. Yes. So can I say that at room temperature, simple room temperature, these electrons will gain some energy. What would happen? They would simply just leave their shell and will simply just out from its shell. Now here, this electron will go where? In this copper wire, you have so many positively charged nuclei atoms. So can I say once it will leave its own atom, it will be simply attracted by another nuclei positive charge. Can I say yes? So here we can easily observe that the electrons simply they are leaving their atom, but they would attract by another positively charged atom. What would happen? So many electrons are there, they are moving into the random direction. So the conductors which conduct electric current by movement of electrons. So in the metallic conductor you have so many electrons which are moving in a random direction. But is there any chemical change? What is the meaning of chemical change? As we have studied any type of chemical species who are reacting with each other, they would form a new substance, any chemical decomposition like ion formation. Any kind of thing is there? Nothing is there. So those conductors, they are simply passing the electric current through them with the help of these negatively charged electrons. They are known as your metallic conductors without any chemical change. There is no chemical change. In the previous one we have studied in the HCl, there is some chemical change. That's why what would happen? The current is passing through them. These free electrons are producing here. They would go from one anode to cathode. What would happen? The current is passing through them. Okay, and the current will conduct from positive to negative terminal easily. So these charge carriers, they charge carriers were responsible for there. In the metallic conductor, these free electrons are capable for this. Now metals, copper, silver, iron, aluminium. These are the example. They have a free valence shell electrons. Now in the non-metals you have graphite. Graphite, as we know, it is made up of carbon atoms, and we know that carbon has 4 valence shell electrons. 3 are involved in the bonding and 1 free valence electron is there, that is delocalized. What is the meaning of delocalized? Its position is not fixed. It is completely randomly moving in all the structure. Okay, so what would happen? This is responsible for the electricity conduction. And various alloys and minerals, these are the examples. So many alloys are also there, that is also capable for electricity conduction. And so many minerals are also there, that is also capable for electricity conduction. Now, electrolytic conductors. Electrolytic conductors are what? Those substances whose aqueous solution conduct the electric current and which are decomposed by the passage of current and are called as electrolytes. See students, you can easily understand. What are the electrolytic conductors? Now here with this word you can understand, electro means what? Electricity. Lytic means breakdown. Conductors which has a capability to conduct. So we can easily understand, once you are passing the external electricity with the help of this lysis process, means breaking down of any chemical species, and these charge carriers, these ions, they are responsible for the electricity conduction. That is known as your electrolytic conductor. Now understand with the help of this. See students, with the help of this diagram you can easily understand, there is a beaker in which you have a electrolytic solution. Electrolytic solution, suppose you have filled any kind of solution is there, like NaCl plus water you have filled here. Okay, NaCl you have taken in a fused form plus water you have added. NaCl plus water, once you have added, what would happen over here? You have these 2 electrodes. What is the meaning of electrodes? The rods which has some charge, and once you passing the electric current through them, there would contain some specific charge. If any rod having positive charge, that is your anode. If any rod having negative charge, that is your cathode. An easy term you can easily understand, the rod which has a positive charge, after what, which is connected with the battery's positive terminal, it has a positive charge. The side which is connected with the negative terminal, that is negative charge, that is your cathode. So here we can easily understand the battery, here connected it is, there is an anode, cathode, and you have what? You have this NaCl plus water, the electrolytic solution. The solution in which you will pass the electricity, it will be simply break down into the ions. That is your electrolytic solution. We can easily understand, electro means electricity, lytic means breaking down solution. Okay. Now here, once you are passing the electric current through them, what would happen? It would be simply dividing into the ions like Na plus, Cl minus, H plus and OH minus. See students, actually what happens in this chemical phenomena, NaOH would be formed, and you would observe that Cl minus would attract it towards to this anode plate, which is positively charged plate, and in the cathode, which is negatively charged plate, so H plus ions would be attracted there. Now some students would ask, why ma'am Na plus and OH minus are not going there? So there is some reason behind that we will study in the product of electrolysis in the further lectures. So don't worry about it. There is a concept behind this. Now here we need to only understand the electrolytic conductors. So Cl minus, that is negatively charged ion. Now this ion would be attracted by this positively charged plate, but just to deposit on this plate, see any plate, it has only atom, not ions. So if any ion, if it will just go here, How it would become stable? After losing the electron, can we easily understand? After losing the electron, it will be convert into the chlorine atom. So what we are observing, that the electrons are producing on this anode part. Now, when the current is passing from this positive terminal, the electrons are going through this electric wire from this here to, from anode to cathode they are going. And once the electrons are going here, what would happen? We would observe that the H plus ions, which would be attract towards to this cathode side, this negative side, they would gain that electron and would convert into the hydrogen atom. And after that some time it would be converted into the hydrogen gas. Suppose this type of thing is there. So what you are observing, you are simply passing the external current. Electrolysis process will be there, ion production will be there. After that respective atoms will be deposited there and the electrons are going from here to here. What we are observing, the electric current conduction in this complete circuit. See students, circuit simply you will understand, ma'am, this is my positive negative and this is my metallic plate I have applied, this is my metallic wire, suppose copper sheet. Now this is the current which is from positive to negative terminal, it will be flow simply. That is my what? That is my simple electric current circuit is there. Okay, this is my complete circuit. Now, how this phenomena is also circuit. We can easily understand, this is my battery, these are my electric rods. In the place of this metallic sheet, we have placed an electrolytic solution. We can easily understand, in the place of this, we have applied this electrolytic solution. This electrolytic solution is capable to pass through this current from positive to negative. How it's possible? With the help of these free electron, which are just going from where to where? Electrons are going in from anode to cathode. As we know, if current is going in this direction from positive terminal it is coming, so electron will go into the opposite direction of current. As we know, the electron will flow in the opposite direction of the current. So it will go from here to here. As we know, in this wire, if electron is flowing in this direction, so can I say the current flow would be start in opposite direction? Yes. Now here you can easily understand the current conduction is possible from positive to negative terminal with the help of these free ions. Now it's clear to you. Now after that, non-electrolytes. What is the meaning of the non-electrolytes? Substances whose aqueous solution do not conduct the electric current, that are known as your non-electrolytes. They have no capability to conduct the electric current. Now, why the electrolytes, like electrolytic conductors, they are capable to electricity to pass through them? Because they have a free ions, the charge carriers are there. These charge carriers, they have a capability to move to the respective electrodes and they have a capability for electron producing, electron lossing and gaining process, that is also possible. Okay. So with the help of that, you will see the electric current will be passed through the complete circuit. Okay. Now in the non-electrolytes we are observing, they have no capability. So it's simple meaning they have no charge, like they have no free ions, no charge carriers are present there, they have no free ions, they have no tendency to pass the electric current through them. Now these are the non-electrolytes. They do not conduct in the fused state as well. Suppose we are talking about the cane sugar, glucose, urea. In the case of glucose, if you will see its formula, C6H12O6. In the case of urea, what is the formula? NH2CONH2. They all are in a molecular form. Sugar, C12H22O11. See students, you can easily understand they all are covalent compounds. They have a covalent bonds are present. There is no ions are present. All are in the atomic molecular form. So with the help of this, we can easily understand they have no free ions which are responsible for electricity conduction. So these are non-electrolytes. Now strong electrolytes are what? Electrolytes which are completely ionized in aqueous solution or in their molten state, these are what? Strong electrolytes. They can simply what? They can simply completely ionized in aqueous solution and in their molten state. Strong electrolytes are those electrolytes, they have a very good tendency, a very fast tendency to decompose into the ion form. We can easily understand like NaCl, HCl, NaOH, strong acids and bases. They are simply having a tendency, if you have passed a very small electricity, the complete quantity of that substance that would be easily divided into the ions form. We can easily understand. Suppose you have taken the 1 mole of HCl and you are passing the electricity through it. 1 mole of HCl would be completely divided into the 1 mole of H plus and in the Cl minus, because it's a strong electrolyte. Means once you are passing a very small amount of electricity, it will be completely divided. Whatever the whole amount is present there, that would be completely ionized in one step. So these are the strong electrolytes. They take a very less time and a very less amount of electricity to convert into their ions form. Now, all salts, strong acids, strong bases. Suppose in this example, if you are taking in place of HCl, you are taking the NaOH. So that would also completely divide into the ions form and it can easily conduct the electricity as well. So that is your strong electrolyte. Weak electrolytes which are not completely ionized in aqueous solution or in their molten state. They have no capability to completely ionize. They would ionize, as we know they are electrolytes. Electrolytes means what? Once you are passing the electricity, they would divide into the ions, but in comparison to strong electrolyte, they would take some time to completely divide into the ionic form. Okay, so we can easily understand you are passing a very much amount of electricity is there, but their complete amount would not be divided into the ions form in a one step. It would take some time. Like we can take an example of all organic acids, CH3COOH, HCN, ammonia, amines, they are the example. You are passing the electricity from 1 mole of acetic acid. Is it possible that it would be divided completely in one step? No, it's not possible. You are passing a very much amount of electricity. A very small amount of 1 mole of CH3COOH would be ionized and it would produce the CH3COO minus and H plus. Okay, so weak electrolytes, they would not completely ionize in aqueous solution. Okay. Now, there is another example of H2CO3 like carbonic acid. That is also a weak acid. It would also, once you are passing the electricity, it would take time to be ionized, and 1 mole of, suppose you are taking, it's not possible that in one step it would be completely ionized and would produce the H plus and CO3 minus 2 or bicarbonate ion we can say. Okay, it's not possible. So these are the weak electrolytes. Now it's time to understand the differentiation between the metallic conduction and electrolytic conduction. Metallic conductors, we know, those are capable to pass through the electric current with the help of their free electrons which are present in the metallic sheet. Electrolytic, they are free ions. They have a capability to go towards to the opposite electrodes, and with the help of this they would easily conduct the electric current through the solution and then they can easily conduct them. Now, flow of electricity takes place without the decomposition of the substance, as we have studied in the metallic conductor. In the metallic conductor, with the help of this diagram, you can understand there is a bulb connected with this metallic wire. There is a metallic sheet and there is a metallic what? This is a metallic wire and there is a battery connected over here, positive and negative terminal. What you would observe? You would observe that you have just simply passing the current through here. What would happen? It will be glow. When it will glow? When the current will conduct from positive terminal to negative terminal, then it would starts to glow. Okay, we can easily understand now. Once the current will reach from positive to negative terminal, then it would starts to glow. Why this possible and how this possible we would understand in the next class, and there are so many examples and so many differences between them. We will understand in the next class how the metallic conductor would work, why the metallic conductor is responsible for the electricity conduction, why the temperature increment would increase the resistance there, and in the electrolytic it's not possible. So all the questions answers that we'll understand in the next class. Till this class, I hope you all have understood the basic strong electrolytes, non-electrolytes, the basic concepts of the electrochemistry. So in the next further classes, we would study so many topics related to the electrochemistry, the complete chapter in the sequence wise we would understand along with the questions also. Stay tuned. Thank you.